At this point, we'll be talking about mass-mole particle relationships. This will be just a continuation of our discussion in the mole concept and Avogadro's number, also with that of the formula mass and molecular mass. Let's start. Now, this particular image shows you the relationship between mass, number of moles, and number of representative particles of a substance. Say, for example, if you're provided with mass and you want it to convert into unit mole, the factor that you need is molar mass. So you need to divide mass with molar mass. And then if you want to convert mole back into the unit mass, you simply, again, use molar mass and then the operation is different. That will be multiplication. Now, what about when you're provided with the unit mole? So you just simply multiply mole with Avogadro's number, 6.022 times 10 raised to 23, to get the unit particle. Again, the unit particle or elementary entity is just it's just an elementary word or not elementary word, but rather an umbrella term or umbrella word for atoms, molecules, and formula units. Now, say, for example, on the other hand, you have particles, atoms, molecules, formula units. You want it to convert back into mole. You divide it by the Avogadro's number. Or say, for example, you're given with the unit mass and you're asked to compute for the number of atoms or any other elementary entities. This will be the procedure. Mass divided by molar mass. You now have the unit mole. Next step is multiply with Avogadro's number. And then on the other hand, if you're provided with the unit elementary entities and you want it to convert it into mass, particles divided by Avogadro's number. Now you have the unit mole. Multiply it further with the molar mass of the particular substance at hand. Okay? Do not worry, I'll explain the steps on how to compute this particular relationship step by step. Let's start. Mass-mole particle relationship. Now, using the following factors, we can convert mass, mole, and representative particles between themselves. So meaning to say, these are just the two particular factors that we'll be using over and over if we are going to compute for the mass-mole particle relationship. Ulitin ko po, ang Avogadro's number at molar mass lang po ang paulit-ulit na gagamitin nating factor or seemingly conversion factor para po mag-convert ng mass-mole particle relationship. Okay? Kumbaga sila po yung maging conversion factor na parang meter to kilometer, kilometer to mile. Yun yung idea. Sila yung conversion factor. Ito pong sila Avogadro's number at molar mass. Okay? The following conversion factors will be used in computations involving moles of a substance. So 1 mole of substance all over molar mass, or you may actually use 1 mole of a substance all over 6.022 times 10 raised to 23 representative particles. Ito po, yung Avogadro's number. Mole is equal to atoms, molecules, formula units, and then the unit for molar mass is your gram per mole. This particular bit is your molar mass, 1 mole all over the molar mass itself. And then this is the Avogadro's number. Avogadro's number as conversion factor, 1 mole all over the representative particle with 6.022 times 10 raised to 23. Alright, at this point, let me show you an example on how we can compute mass-mole particle relationship. Let's start with mole particle. Okay, so let me just read the problem first. How many molecules are there in 5.50 moles of glucose? So you have here the formula or the chemical formula for glucose, and then we have the given here. So let me write 5.50 moles of glucose, C6H12O6. So the instruction is to convert mole into unit molecule. Okay, so we are just applying what we've learned in dimensional analysis. That's the idea behind this one. So with that said, we will be having a conversion factor. Now the conversion factor to convert mole to molecule, the conversion factor to be used is what we call your Avogadro's number. Let me repeat, Avogadro's number. Okay? If you're going to compute or if you're going to convert mole to number of particle or number of particle into number of mole, the conversion factor to be used is your Avogadro's number. So I'll be using Avogadro's number. So Avogadro's number, as we all know, is 1 mole is equal to 6.022 times 10 raised to 23. So 1 mole times 10 raised to 23 elementary entities, or any elementary entities. May that be of atoms, molecules, or formula units. So I will put 1 mole here at the denominator. Why? Again, to cancel this unit. And then at the numerator, 6.022 times 10 raised to 23 unit molecules. Again, any elementary entities. Now at this point, mole is cancelled. I now have my desired unit, molecules. Easy, very easy. I now have my final answer here, or final unit. Now input this one on the calculator. Okay, so I have the same solution with the PowerPoint. So input this one on the calculator. 5.50 multiplied by the quantity 6.022. This is times 10 raised to 23 all over 1 over 1. I have this answer. Again, my only given is 5.50. This conversion factor is not part of my candidates for least significant figure because they are exact number. So 5.50 has the least sig fig as 3SF. So my final answer should only have 3 significant figure, 3.31. 3.31 times 10 raised to 24 molecules. Okay, so glucose molecules, C12O6. This is my final answer. Okay, so I have the same answer, 3.31 times 10 raised to 24 glucose molecules. Okay, again, if you want to convert mole into particle, your conversion factor is Avogadro's number. If you want to convert particle back into mole, you will use Avogadro's number again. Okay? Okay. Next example. What about mass to mole conversion? Iron corrodes to form red-brown rust or iron 3 oxide, Fe2O3. How many moles of iron 3 oxide are contained in 85.5 grams of pure Fe2O3? So let me write the given, 85.5 grams of Fe2O3 or iron 3 oxide. What I'm required to do is to convert gram into unit mole because the question or the required is moles. How many moles? So looking at this bit, I need to convert gram into unit mole. The conversion factor best to convert gram to mole is what we call molar mass. The unit for molar mass is gram per mole. Okay, so I'll be using molar mass. Now, the value for the molar mass is not, hindi siya nakukuha sa hangin, hindi siya magic na nakukuha natin. Paghihirapan nating hanapin si Fe2O3. Naalala na ang pag-compute ng molar mass ay tulad ng ganito. So we need to compute for the Fe2O3. How? First is account the number of atomic masses for each element. So we have iron and oxygen. So iron is this one, 55.85. So I'll be getting up to 2 decimal places, 55.85 AMU. And then for oxygen, 16.00, this one. 16.00 AMU. Next step, multiply by the respective number of atoms. So iron has 2, so I will have times 2. Oxygen has 3 subscript and then times 3. So input this one in the calculator. Specifically, you have 55.85. Sorry about that. 55.85 multiplied by 2. I have 111.70 since this is 2 decimal places, okay, 0.70. And then 16.00 times 3, I have 48.00. 48.00. Then add them up, I have 111.70 plus 48.00. I have 159.70 AMU. So at this point, I already have Fe2O3 is ionic compound, so I have the formula mass. Can I use this particular given? No. What I need or what we need is molar mass. So we need to convert formula mass to molar mass. How? Remember, molar mass is equal to formula mass. So we just simply have the equality. Molar mass is also 159.70, but the only difference is the unit. Instead of using AMU, we use gram per mole. So 159.70 gram per mole will be our conversion factor. So gram per mole. Gram per mole will be the unit. So since grams need to be cancelled, I put grams here, and then I put moles at the numerator. This will be 1 mole. Remember, when we say gram per mole, gramo kada isang mole. Ayan o, gramo kada isang mole. So kaya siya 1 lagi. Okay, pag molar mass, 1 lagi ang value niyang kasama ng mole. Kaya siya gram per mole. Kada isang mole. Itong grams, value ng grams, ito yung 159.70. 159.70. Cancel grams. I now have my desired unit mole. Okay, so input that one on the calculator. I actually have the same solution with that of the PowerPoint. So 85.5 divided by 159.70. Let me show you a much complete solution. Multiplied by the quantity 1 all over 159.70. I have this answer. And then again, this is least significant figure because we use multiplication. 3 sig fig. So I'll be only copying this particular bit. 0.535 moles of iron 2 oxide. So I have the same answer with that of the PowerPoint. Okay? So let me repeat. If we want to convert gram into unit mole or to convert mole into unit gram, we will be using the conversion factor molar mass. So then again, if you want to convert gram to mole or to convert mole unit back to gram, the conversion factor that we will be using is molar mass, which has a particular unit gram per mole. Okay? So again, if you are the molar mass is most of the time not provided in the problem. So say for example this one, we do not have the particular given molar mass Fe2O3 which is 159.70. Magko-compute po tayo from the scratch. May time po na ibibigay na tong si 159.70 pero pag hindi po binigay, gagawin natin itong parte ng ito. Okay, so magko-compute tayo from scratch para lang makuha tong 159.70. Pero pag binigay, thank you Lord. Pero kung hindi, i-compute natin to. Okay? Okay. Next, last example. Now, what about we are going to compute or translate mass mole particle? Okay, seemingly there will be a challenge. So let me read the problem. How many atoms are there in 11.3 grams of lead? So let me write the given 11.3 grams. Okay, so that will be grams of lead. So we need to convert grams into number of atoms. Okay? So looking at this one, it looks like we will be needing 2 parentheses or 2 conversion factors because there is no direct translation for gram to atoms. Okay? Just like what we did in measurements, okay, there is no, some examples shows us no direct conversion factor, so we'll be using 2 conversion factors, okay? So first, I'll be using the conversion factor. First is molar mass. I'll be using molar mass. Second is Avogadro's number. Okay? Avogadro's number. So let me start with molar mass. So let me start with the molar mass of lead. So the molar mass for lead, first is we need to go to the periodic table and look for lead. Lead is Pb. Lead is actually this one, 207.20. So 207.20 AMU. And then again, we know that molar mass is equal to atomic mass as discussed previously. Okay, so therefore we have 207.20 grams per mole. So I'll be writing 207.20 gram per mole here at a particular solution. So I have 1 mole at the numerator and then 207.20 grams here. Grams will be cancelled. I now have the unit moles of lead. Okay, so is this the final answer? Not yet, because what we need is the unit atoms. So the second conversion factor shall be used, Avogadro's. So remember, Avogadro's number or Avogadro's conversion factor is 1 mole is equal to 6.022 times 10 raised to 23 any elementary entities such as atoms. So pwede gamitin. So I will use 1 mole here at the denominator to cancel the unit mole and then 6.022 times 10 raised to 23 atoms here at the numerator. At this point, I have the desired unit atoms. I may now stop and compute or input this one in the calculator. So input this one in the calculator. I have 11.3 multiplied by the quantity 1 all over 207.20 multiplied by 6.022. Sorry about that. Let me write 6.022 times 10 raised to 23. This should be all over. Let me write again. Sorry about this one. 6.022 times 10 raised to 23 all over 1. So the answer is this. But then again, we should follow correct significant figure. 3 significant figures. So this must be 3.28 times 10 raised to 22 atoms. So let me check if I have the correct answer with the PowerPoint. I have the same solution, and then the answer is 3.28 times 10 raised to 22, okay, sorry about that, 22 lead atoms. Okay, so lead atoms. Okay, so let me give a wrap up. If you want to convert mass mole particle, so that could be gram into mole into any elementary entities, or and the other way around, elementary entities into mole into number of grams. The conversion factor that you will use is molar mass and Avogadro's number, just like this one. Two separate factors. Okay? It's just like measurement, the things that we've done in measurement. This time, we apply dimensional analysis or measurement in chemistry, literally. Okay? So let me give you a wrap up. If you want to convert mole to particle or particle to mole on the other way around, you will use Avogadro's number. Again, mole to particle or particle to mole, use Avogadro's number. If you want to convert gram to mole or unit mole to gram, please use molar mass as the conversion factor. And on the last part, if you want to convert gram to elementary entities or elementary entities into unit gram, you will use two conversion factors, molar mass and Avogadro's number. You will use it depending on what is needed. You may use Avogadro's first, or you may use molar mass first, or molar mass first and then Avogadro's, depending on what is required. Okay? So that's it. Thank you everyone for tuning in. I hope you learned a thing or two for this particular lesson. And then next video, I'll be discussing more about stoichiometry. Thank you and have a great day.